Now, this data represents an example from a manufacturing sector. Let's suppose we would like to compare the mean content of the two popular brands of soap bars. Their advertised quantity is mentioned on their wrappers or packets as 125 grams. Before supplying anything into the market, they conduct a sample survey. They pick some random bars, soap bars, and then they determine these two important parameters that are representing the entire population. And this is point of interest for us as a student of statistics. These are their population means and their standard deviations of the population. So let's suppose that first brand of soap bars has a mean content of 124 grams. Second has a mean content of 122 grams with the standard deviation of 10 grams and 8 grams respectively. Over here you can take notice of one thing, that these two standard deviations are of population data. And what if we have drawn the samples of size 36 and sample of size 40 from these two brands respectively? Now, we need to first assume this thing, that random variable x1 or x1 bar follows normal distribution with mean mu x1 bar and variance sigma square of x1 bar. So if we write this down in numbers, so we'll assume that x1 bar will follow mean of 125 grams as stated in the question, and standard deviation squared is 10 grams. Similarly, for the second one, will first write down in terms of notation, and then we will write down it in terms of the numeric values associated or we are given in the question. So now x2 bar follows normal distribution with its mu value, that's 122, and its sigma x of, just erase these notations because we need to specify square root of sample sizes along with that as well. So these are just variances or standard deviation specifications. Now, what if we are asked to determine the probability? What is the probability that the mean difference is less than 3 grams? What is the probability that the mean difference is exceeding 5 grams? What is the probability that the mean difference may fall between 4 and 6 grams? So let's consider the first three parts to answer first. Now, what we need to do, we need to compute this value and compute the denominator at the first place, because this we will use frequently then. So mu1 minus mu2 is simply 124 minus 122, and that's 2. So this is the value of mu1 minus mu2. Now to compute the denominator part, which is equal to this, and over here at the time of substitution I would highlight the mistake or common error that students make in the exam. What students do, that when they substitute the sigma value, they forget to raise this to square. That you need to focus on, and don't forget, please. Here as well, 8 squared divided by 40. Now I am working out this on my part, and you need to work it out on your own as well, on your part. So that's 10 squared is 100 divided by 36, and plus 8 squared 64 divided by 40. Then we take square root of the answer, and that's 2.092. So take it as 2.09. So these two values we get, and this is the answer after taking square root of this entire thing. Now, considering the first part, we will now use the formula. In the first part, the value of z, or the value of sample mean differences, is given as 3. The difference between these two population means we have worked out as 2. And this denominator part we have worked out as 2.09. Now we get it transformed to the corresponding z value, and then we'll consult the z table to work out the answer. The z value we got is 0.478, that we can round off to 0.48. Now we refer the z table and quote the answer, that z is less than 0.48. Now we go to z table, yeah, that's the z table. So we have to go to the second page of the z table, because first page of z table is for negative values of z. So no, 0.4 is this row and 8 is this column. So 0.6844 is the answer. 0.6844 or 68.44% is the chance for this, that the sample mean difference will be less than 3 grams. Now we know that whenever greater than sign is involved in the sample mean differences, we need to first transform it to z, and then we will take away that probability from 1. So I'm now going to transform this to z first. That's 5. Take away 2, which is mean, divided by 2.09. So 5 minus 2 is 3. 3 divided by 2.09 would give us the z value of 1.435. So 1.435 we can round off as 1.44. So this time z is greater than 1.44 we are asked for, that we need to first transform to the structure, because z table only gives us the probabilities below a particular value of z, and this is how we can restructure this to get our answer. Now we again go to z table and locate the z value from there. This time 1.44, so 1.4 is this one and 4 is this one. 0.9251 is the probability. So 0.9251 So 1 minus 0.9251 gives us 0.0749, or 7.49% is the chance that the sample mean differences will be exceeding 5 grams. Now, to answer part C, we need to transform both the bounds of 4 and 6 to corresponding z values. Again, the working is z1, we can refer it as, so 4 minus 2 divided by 2.09, that's 1 point something, I believe. 4 minus 2 is 2 divided by 2.09 would be 0.9569. So 0.96 we can take this value as. And z2 if we take, that's 6 take away 2 divided by 2.09. So 6 minus 2 is 4. 4 divided by 2.09, 1.9138. So 1.91 we can take it as. So that's 0.96 and this is 1.91. Now what we do, we read out the probability corresponding to 1.91 from the table first, and then corresponding to 0.96, and we subtract the two. So we take the z table as 1.91 is this probability, 0.9719 is corresponding to the z value of 1.91. So 0.9719 take away, now we again consider the z table for the z value of 0.96, so that's 0.9 and this is 0.6, 0.8315, 0.8315. Now we subtract the two. 0.9719 take away 0.8315 is 0.1404, or 14.04% is a chance that the sample mean differences may lie between 0.96 and 1.91. Now what I'm doing, I'm adding some more parts to it. That's part D. Let's suppose part D is asking you to determine the sample mean differences to be less than A, and corresponding to A there is a probability of 0.2. Now what we do to answer this, we first draw the sketch so that we can get this 0.2 located. Look at the sign. Sign is less, so it does indicate area below A is 20%. So this is the probability. A is this value. Now what we do, we again consult the z table to obtain the z value corresponding to 0.2 probability. Now we go to the z table. We know that 0.2 is the probability which is less than 0.5 probability. Therefore, we can get it located in the negative z table. And this is the value 0.2005. You can recall this value we have used earlier on. And this is in the row of minus 0.8. And this is in the column of 0, 1, 2, 3 and 4. So minus 0.84 is the value. So the value for A is minus 0.84. What we do now, in place of Z in this formula, we will substitute minus 0.84. Sample mean differences x1 bar minus x2 bar is given as A minus population mean differences is 2 we have computed as, and the divisor or denominator factor standard error we have computed as 2.09. So what we do, we multiply these two together and then we move this 2 to the left hand side. This is how we can answer. The working is minus 0.84 needs to be multiplied by 2.09 and then we add 2 to it to get the answer for A. So 0.84 with the minus sign must be multiplied by 2.09 and then we add 2 to it. So that's 0.2444. So A has the value 0.2444 grams, and this is the this can be interpreted as the difference or the maximum value for the 20th percentile for the differences between sample means. Now adding one more part to it. This time I'm indicating this as B and changing the sign and taking a different probability of 0.3. Now what we do, we again draw the curve, and this time since gradient sign has been used, so B must be located on the right part under the curve. 0.30 is the probability that we assign over here. This won't help us to get it located because T table it gives us the area below, so we need to immediately transform it to area below. If the area above the borderline is 0.30, then the area below would be 0.70. Now we take this 0.70 as the value of the probability and we start locating this probability or value corresponding to zero point 0.7 probability in the Z table. And since 0.7 probability is a probability exceeding 0.5, therefore we need to go to positive Z table. Now 0.7 probability we need to get located in the table, and that's between 0.6985 and 0.7019. So we can find approximately nearly somewhere in the middle our target probability of 0.7, because neither this value nor this value is giving us exactly 0.7 probability. This is a deficient. This is this has a deficiency of 0.0015. This is exceeding 0.0019, so we assume that these two neighborhood values are exactly at or nearly at the same distance from the target value. So what we do, 0.52 is the destination of Z for this probability and 0.53 is the destination value of Z for this probability. So we take the average of 0.52 and 0.53, and the average of 0.52 and 0.53 is 0.525. So the value of Z corresponding to B is 0.525. Now what we do, we solve it in the same way. We substitute 0.525 as the value of Z. We substitute in place of x1 bar minus x2 bar its specification as B. Take away the mean differences of 2 and divide this by 2.09. Again, 0.525 must be multiplied by 2.09 and we add 2 to it. This is how we get the answer for B. And now 0.525 multiplied by 2.09 plus 2 gives us 3.970 3.09725 as the answer to B. Now I am adding one more part to it. That would be the last part of the question. And this time, this is indicated as C, the lower bound, and the upper bound as D. And we are looking for the two values of Z based upon this 90% probability. Over here, C and D are assumed to be the two border lines that are at the same distance from the center. This should be specified over here. C and D are at the same distance from the central value of the curve, that is mean. In this case, the difference between two population mean. So this we can consider as the two values for 90% CI. These are, you can recall, minus 1.645 and plus 1.645. So for C, we take the lower bound, and we do the same thing. And for D, we take the upper bound, that is positive value of C. Now we can work out the answer in the same way. We need to multiply 2.09 by minus 1.645 first, and then we add 2 to the answer, and this is how we get the sample mean differences to be minus 1.43805, and the value of D is, again we need to do the same thing. 2.09 must be multiplied by 1.645, then we add 2 to it, we get 5.43805. So this is how we can use Z as a sampling distribution for the differences between two means. We must be given the corresponding population mean values along with the population standard deviation values and the sample size that we are going to draw, along with these specifications what I have mentioned from part A to part F. Okay, so that's the end of this session.